All right, welcome everybody to another episode of Labs Talk. How are you? How are you,
Welcome,
Andres?
welcome to another episode of Labs Talk. I promise to look at you, Sven, right?
Oh, now I feel intimidated actually.
Like
So,
it's another
all right.
episode, and we're going to talk about aerospace topics for the
Yeah,
next quarter.
I mean, it's an exciting series that we have that we're part of here, right? So it's gonna be about space. In this particular episode, we're gonna talk about space imagery, drones, planes, and how we drive actions from all these images with an incredible platform, I believe. So it's a very cool topic and nothing that we had before, actually, right? So far, we
No,
talked about quantum and AI, of course, right? But we kind of stayed on this, I would say, within the boundaries of this planet. Yeah.
yeah.
So,
And this quarter, we're going to talk about different players from
mm,
aerospace and defense. We are going to have guests that are from the defense. As always, we're going to have guests that are from academia, from
yeah.
startups, from corporate. And we're going to bring in a couple of different angles. But for today, we are going to talk with a fairly new company, and we're going to talk to Sergey from Flypix AI.
Okay, perfect. Let's bring him on. Okay, welcome, Saye. How are you doing?
Hi. Thanks. I'm good. Thanks for letting me being here.
Thank you for being our guest, Sergey. To start with, you tell us a little bit about yourself.
Sure.
Who who are you, and what's your background?
Yeah, absolutely. So I'm a co-founder and CEO of Flypix AI. We are a company from Darmstadt. I'm a technical co-founder, studied here at TU Darmstadt, electrical engineering, signal processing, machine learning, and then did my PhD in this domain, and then was fascinated with the Earth observation, with looking on Earth from skies and from space, and this is what I'm doing now on the daily basis.
Sergey, let's go back slightly further than that. Like you told us, you did a PhD in digital signal processing, but what actually was it that got you there? I'm pretty sure you haven't been hasn't been your childhood dream to digitally process signals, but really, what got you so excited about that particular career path, and what happened that you went into that idea that resulted in Flypix AI ultimately?
Yeah, I mean, from my early days, I was interested in technologies. I was programming since my childhood. Was creating different apps, different games. So this is what was my passion. And then I also was interested in hardware. So I decided to go for electrical engineering with my studies. And then what I discovered there is that electrical engineering it's not only about electricity and hardware, but it's also about signals. And signals is something that we are transmitting to each other. It's something that we are reading with our sensors from different from different sensors and different modalities. And then I realized is this is very similar when you read something from as electrical signal or some other signals, and you are using the same methodologies, the same algorithms. And this way, I slowly transitioned into the analysis of this signals processing, and then also machine learning. It has great overlap with this. Yeah.
But to add to that, like we had a pre-chat before we did speak already. You're doing a lot of satellite image processing, and the one thing that I asked myself that has been around for a while, and satellites. Like I was excited about space and satellites when I was a kid, like 40 years back already by now. And satellite image is not a new thing. And you already told us, but tell our audience as well, like what's the new idea that Flypix AI brought in, and what sparked that idea to found this company?
Yeah, in general, when I was entering this field, it was around 2017 when I first tried this type of data or applying machine learning on this type of data. So what I realized is that the domain of Earth observation or remote sensing, it's quite conservative in a sense that it's using classical tools and algorithms to get insights. There was a reason for this because sensors at these times were quite, I would say, coarse, so low resolution, and you were not able to see in details what's happening on the ground. So you were working more on fields, understanding different indices or different scores or risks on the high level. But then what we started to see is that we are getting more and more high resolution imagery, more quality imagery, and you are able to automate a lot of decision making based on machine learning with this type of data. And this is practically where we've seen opportunity and then created our company 2023, but it was a long path before this, obviously.
Also in the pre-chat, you told us, I think the way to see the AI platform that you created is it's basically an intelligence layer for imagery, right, from space. So can you explain a bit what you mean with that, basically? What's possible with this intelligence layer?
Yes, absolutely. So what we are doing, we are building intelligence layer to process the imagery from space or from the skies. So it's aerial imagery or drone imagery. And why do you need typically this? So we are getting vast amount of this kind of data, this imagery. This data is extremely complex to analyze, to process, extremely complex just to transfer from one location to other location, because it's really hundreds of gigabytes of data that you need to transfer, and then you need to analyze it with your eyes potentially as a human, right? So it's very difficult to do this. And think about of the use cases when you need to do the same analysis of the same place on the daily basis. It means that you need to just sit in front of the monitor, analyzing hundreds of square kilometers potentially. You need to be very precise. You need to be very attentive to details. And this is something that you can obviously replace, right? And then this was our idea when we start this, or automate. And this is how we created Flypix AI, to really extract from these pixels information that we humans need, that we humans understand, and then we humans can work with. So extract semantics, as we call it. So
Yeah.
this kind of representation of this imagery that we can then operate for our monitoring, inspection, and detection tasks.
Let's go into the semantics that you mentioned just for a very brief part. What type of semantics, what type of information is it that you detect, that you use that intelligence layer for, and that it will be created from that images? What is it that comes out of that?
So when you look at a satellite imagery that is pointing to a forest, right? So what you see or what you get from signals or from sensors, you have some green areas, right? So with your eyes and your brain, you can extract these semantics, and you can say this is a forest of particular type, right? And what we are doing with Flypix AI platform that we built, we are automating this process, and the platform tells exactly this is a forest. This is the area actually that is not a forest anymore. This is a deforested area. This is a river next to this, and this is the mountains, right? And then you automatically get kind of a map or representation of your reality based on these images. So you don't need anymore to watch or look at this imagery and interpret what is this? Is it a tree or not? Or where the deforestation happened, but you can directly consume this kind of information for your decision-making process.
Just so to keep this super practical, so this basically means I could ask this platform a question like how many square meters are covered by trees, for example, right?
Yes.
Yes.
In case, if you have the right data for this, absolutely, you can ask this kind of questions.
Okay, cool. I think the next thing we also touched on it in the pre-chat that is very interesting, I believe, is whenever something changes, basically, right? Let's say a tree changes into a no tree area, basically, right? Because it was removed, basically, right? Or it was deforested. So that's also possible, and then you can basically trigger outside systems, I assume, right? So
Yes.
what are some of the applications here?
Absolutely. So one of the mainstream application that you bring or apply on top of this kind of semantic layer is the change detection analysis. So you want to understand what has changed on the image, if anything changed, to what extent. And there are multiple ways how you can do this. One of the ways is you extract the semantics, and then you see how this semantics changes. For example, as you mentioned, there was a tree at timestamp one, for example, a year ago. Now there is not a tree anymore, and here is the change, right? And the system can identify this change, it can highlight it, it can georeference it, it can tell you where exactly it happened, to what extent, and then you can trigger different workflows. You might have maybe an SMS or a notification to your email, or you can integrate it into your workflow, maybe ERP workflows, and then get particular processes triggered.
Mhm.
Yes, and you can think of this in a more generic way. It's not only about trees, but it could be um, any infrastructure related applications, any defense related applications, agriculture, public domain applications. When we are working with, for example, cities and municipalities who are looking for changes in their infrastructure and environment. So this is universal technology that can be applied into many different domains.
Mhm. Let's go into those different domains and that universal applications. From there, you were talking about how these signals are generated and how you can pipe those in your custom workflow. I feel we got a little bit too technical at that point. I think when a tree turns into a parking lot, sending an email from there, that's probably not a use case by itself. But what would be, apart from being able to send an email, what would be a particular, a practical use case?
Mhm. So a lot of use cases are grouped around compliance monitoring or reporting or progress monitoring. So just give you an example from one of our customers. They're building pipelines, 100 kilometers of pipelines, and what they need to monitor the progress. So obviously you can send a person who would go on the daily basis over this or along this pipeline 100 kilometers and then protocol everything at which stage it is currently at this particular point of time. Or what you can do um, otherwise, or else you can have a satellite picture, or you can fly a drone that can be also automated to a large extent. So your flights can be automated, and then the system that we built can analyze this images and reports you what exactly is there on this location where a pipeline has to be built. Is it on the stage where you just grabbing a ditch, or it's already laid there, or there is a welding process and so on, and then you can see the progress. You can react based on different aspects of this progress because you have a plan, and you can automatically also compare this to the plan. So this is just one of the practical example that our current customer is working on.
I think I want to step back a tiny bit because you just mentioned drones already, right? So we talked about satellites in imagery and then drones. I think another source is also planes. So what are the differences between the sources of images that you have and like when would you use which source basically, and why is it necessary actually that we use, for example, drone imagery?
Mhm. Let's start from satellites, right? So satellites are typically already existing infrastructure, or they are coming, or they are going to exist. There are new launches happening on the, I would say, on the quarterly basis. So this is the infrastructure that you can utilize already today and get the images from there. One big disadvantage, there are a couple of them, but one big disadvantage if we are talking about the practical applications, most of the time our Earth is covered with clouds. And if you want to get visual spectrum images, you're not able to do it with or through clouds. Then you need mobile platforms. It's either airplanes or drones, right? Airplanes, it's kind of also quite I would say old technology. You can just attach a camera there. On the other hand, it might be quite expensive, especially if you need to do it on the frequent basis. If you have local needs, if you have, for example, agricultural field, or if you have particular pipeline that you can really set your drone to fly over, then you are using the drones, and then you don't have issue with clouds. You're controlling exactly where you're collecting the data. You're collecting only what you need, and this is becoming very practical for you.
In to stay in that space for image sources a little bit, I can imagine that there's a huge difference in the quality, not just the say like a drone flies much lower, you're below the clouds and you can see things that a satellite wouldn't see. But I can also imagine there's differences in quality, and those type of dimensions allow you different use cases.
Absolutely. So one of the main characteristics that we are typically talking about is resolution, or camera resolution, or sensor resolution. And obviously, when you are flying a drone, you're able to mount or have very up to date cameras with high resolution. Additionally, you can fly low, getting all the details of what you need. You can see a bug, for example, if you are on the agricultural use case when you have a drone, right? So it's this kind of details, or you can inspect leaves and see if there is a particular disease on these leaves. So this is a level of granularity, level of resolution you can achieve with a drone. When you're flying airplane, obviously you have also some fixed infrastructure. You're not able to fly in extremely low, so you are able to see, for example, to give you a reference, road markings very well, and then you can use
Mhm.
this for many different use cases. When you're using satellites, you are more limited in this resolution capability, and typically what you see is some large enough objects similar to a car or maybe to a tree. But today, practically every year, the sensors are becoming better and better, and soon I'm pretty sure that we'll have also quite quality imagery from the satellites as well.
What I was wondering actually is about the regulatory aspects, right? I mean, when it comes to planes and drones, it's probably not that easy, right? So, I mean, you need to manage all the authorities, right, and the rights to actually start a drone. So, how do you manage this actually with FlyPix?
Yes, so that's definitely one of the let's say difficulty when we are talking about these mobile platforms. We as a company, we are not collecting data ourselves. We are working with our partners, and partners are the companies that are flying satellites, operating satellites, operating airplanes, or operating drones, and they are typically handling all these aspects related to the permissions, no flying zones handling, and everything. So typically, the process looks like this: the customer requests the data and analytics through our platform, and then one of our partners is taking care of the data while our platform is providing analytics, the analysis or the results based on this data. Currently, today, there are companies that are practically Uber for drones. So you can
Mhm.
request an image, and then this company is requesting the collection from one of the local representatives. And we are sitting here in Germany. We can request the data with particular characteristics practically from everywhere in the world.
Be cool.
Does it work the same way for planes and satellites, that you just go and order a satellite like you order an Uber? Because you mentioned that comparison. Like you said, there's companies that allow you drone images as like Uber does. Is that the same for satellites, really?
Um, Similar, right? For satellites, you can request so-called tasking activity when the
Mhm.
satellite would fly above particular area and would collect data for you, right? So you practically send a job to to task this acquisition.
Yeah.
Um, this works. And different satellite providers offer this differently within different packages and within different let's say commercial structures. One important thing is that obviously satellites, especially nowadays, are used for multiple applications, including also defense applications, and there could be different priorities, right? So the satellite might be busy with other tasking activity from more demanding customer, let's say,
Mhm.
and
Mhm.
then you might have
Still
to get your data. Yeah, you might just be delayed with your request. Yes, but this works already, and this is quite common use case to task the data.
okay, but just to round this off, so ultimately this means there's also a difference not just in quality but also in frequency that would probably limit some of the use cases.
Absolutely, absolutely. Different constellations from commercial and non-commercial data providers. They offer different acquisition frequencies. Sometimes, if you are taking, for example, European Space Agency Copernicus program and the Sentinel-2 mission, that is practically multispectral imagery that we are working a lot with. They are providing you the imagery every week, right? On the
Mhm.
other hand, commercial data providers can provide you the imagery on a daily basis or even multiple times per day.
Uh-huh. Interesting. So in a pre-chat, we talked about penguins actually, which I found amazing. I think you mentioned penguin and camel counting, right? Which I found fascinating because it really it shows. I mean, for penguins at least, that it really you need a lot of resolution for that, I believe, right? In my opinion, to count a penguin. But the real question I have is basically who's interested in that, right? And I think you talked about NGOs. So what are the key customer groups? Yeah, you don't have to mention customers, but maybe customer groups that are interested in these kind of services. Let's talk about that a little bit. Yeah.
Yeah, absolutely. So since we built a platform, meaning that this is a technology that is able to be flexible to different use cases and to different customer groups, so we experience a lot of requests from very exotic or niche customers or users, including a lot biodiversity use cases. Indeed, we had requests, for example, to estimate a population of camels in from one of the Middle Eastern countries, and
Mhm.
their public authority. We had a user who was counting penguins, indeed, from a drone footage. So it's a scientific mission. They're going there. They're flying drones, and then obviously you have thousands of penguins organized in colonies, and then you need efficient methods how to count them to then also estimate the population. For example, with satellite imagery, this would be a little bit more difficult task because you would hardly see individual penguin from the space. On the other hand, you can pretty nicely see their groups, their colonies from there, and that would also give you some proxies into the amount of penguins. So it's a lot of if you are talking about biodiversity use cases, it's a lot of NGOs, it's a lot of public sector, it's a lot of ministries that are interested to understanding the population of particular species and then keeping their amounts on a particular level.
Okay, very cool. All right. I think then let's already come a bit to the visionary part, I would say, right?
Yeah,
Towards the end of
absolutely. Like,
our episode. And I'm what I was wondering, right, also is like, does this technology at some point become accessible to all of us, right? I mean, you mentioned customers, NGOs, and other organizations, but do you think this would be something that maybe gets accessible to individuals? Like I could maybe monitor my parking lot whenever my car arrives or something like that. I want to trigger something, or do you think that's possible? Or what is your vision basically for this platform and all for the use of it actually?
Yes, and this is what exactly we are working on to make this accessible. Maybe not to monitor exactly your parking lot, but to make it very accessible not only for B2B users, where our main business is, or B2B, B2G customers, but to everybody. So
Yeah.
what we believe, and this is what we are working hard on, is that this technology will become something similar to what we experience nowadays with the GPS or weather forecast. You might think about this nowadays as a very intuitive technology that is in your pocket, in your smartphone, right? And you just need to click one button to access what you need. On the other hand, a few decades ago, these technologies were very or extremely industry heavy. It's still nowadays like this, but we don't see it, right? So there are satellites behind these technologies. There are operators behind this. In case of weather forecast, there are big AI models, a lot of data, huge amount of data that they're collecting on the daily basis and building large models from this data. But we don't perceive it like this, right? And we believe, and this is what we are working on, that Earth observation analysis, this intelligence that we are extracting from this imagery, will become something that you will carry in your pocket or you will be able to access from your pocket, from your smartphone, from your smartwatch. And this will drive different decisions that you are making on the daily basis, potentially, maybe even a parking spot to see if it's occupied or not, or many others you might have.
Mhm.
awesome. Sergey, thank you so much for the broad and deep insight. It's really amazing technology that you're working on.
Yeah, pleasure being here. Thanks for inviting me.
Very cool. Then thank you so much, and everybody, thanks for watching, and see you next
See you
time.
soon. Thank you for
Bye bye.
watching. Ciao.
See you.